Those are probably my everyday shoes. Mine are trashed.
I just bought a pair of everyday shoes, so I'm good for a little bit.
All right, everybody, we're going to get started. So it's the first week in November. We have like a month and a half until the semester ends, so good fun. Apparently some of you got midterms tomorrow, so good luck with those. Study hard. So now we are about a week away from the end of Phase B, unless we push it. Hopefully we won't have to, but we have a week to put together and start testing a prototype for our final build, so we can get our final build set and ready in December. Some basic info. This picture right here is us at Clark's Planetarium on Saturday. Jane's wife took the picture. Thank you. We were having fun. We kind of had our batteries try to explode on us. You know, a normal Saturday.
Wait, what?
Yeah.
I want to hear about that. But what?
That's story time for later. But our next outreach event is on the 15th. So that's next Thursday. It's elementary school kind of STEM fairs, 2 hours at Riley Elementary. I'm not quite sure where that is yet. I haven't Googled it. I just know that's where it will be. But anyone's welcome to be there. I'll be there with one of the robots. We'll go around and show K through 6 kids our robot. It's from the Google Fiber people. They're the ones that putting this on, so it's kind of cool that we're on the radar. After that, on the 17th, that's that Saturday, we have Engineering Day for the College of Engineering. It's going to be, I believe, in the WEB, and it's just a little 2-hour session with, it's a tabling session with like 3 breaks or something like that. It's simple. We do it every year. So those are our only outreach events this year that we have left, so we're almost done with that. And now we get to the fun thing of buying stuff. So our first purchase order went out this Monday.
Monday, and I'm not sure if there's any feedback on Pam on stuff like that.
She said she'd let me know if she has questions, and she hasn't, so I'll follow up with her today and make sure that it's been ordered.
Yep.
Yeah. So we have started buying things, spending our money. We're going to try and get another purchase sheet put together here tonight, tomorrow, so we can get those final things finished. Mostly it's just for the mechanical team. We need to finalize our NEMA motors and our Digger motors. So when you get those ordered as soon as possible, so when the 14th rolls around, we can throw those on and have electrical wire them up, and we can be good to go. Speaking of spending money, we're going to be staying in the same Airbnb that we went to last year, which is this right here. It's huge. We're right next to the beach. Great working space. We actually, I don't think do we put it on the foosball table?
We put it on the foosball table.
Yeah, we put it on the foosball
We
table.
totally didn't put it on the foosball table.
Our robot is what we're talking about.
Yeah.
We used the foosball table as a build station. This is the same Airbnb where Montana Tech goes, so we're right across a kind of courtyard from them, so it's kind of fun to harass each other. They invited us over to a bunch of stuff, and we tried to go, but we were busy fixing our robot. So that's what we're going to be staying May 6th to the 10th. I will say now that that's when the competition is, but if you plan on going, it's probably best to allocate around 2 weeks, because if you're driving, it's 3 days down, 3 days back, plus the 5 days in Florida, maybe longer depending on what we decide to do. So it is no small time commitment, so if you need to start planning on when to take off work, that type of thing, now is a good time. So the competition is May 6th to the 10th. We'll probably leave the 3rd and get back the 13th. So 10, 11 days.
Who's actually going?
Yeah.
So,
Speaking of breaks, Thanksgiving is coming up soon. With this being a volunteer team, school takes priority, family takes priority, and it's a good time for you guys to rest and relax, so I highly encourage it. Take advantage of Thanksgiving, have fun, but because we are saying that, we also have to make sure we still build stuff while we can while we have you here. So for these sub-team meetings, be it mechanical, mobility, digger, it's important that you guys show up to these and put in some effort there so we can get this built. Thank you to everyone who has been going. We have really great work done. I think all we really have left to do is physically put things together. The design work is essentially finished, which is nice. Social media?
So, for social media, we are 4 people away from having 100 followers on Instagram. So if you have not, make an Instagram account if you don't have it, or just follow the Instagram account. We tested robotics, so we're really close to 100. That's really, really fast for like something like this. So we're doing really good. That's that.
okay, so if you haven't followed us on Instagram, make that a triple-digit number so we feel happy.
I've had an Instagram for 6 years, and I'm at like 23 followers. So, yeah, I know. I feel snazzy.
We can feel happy anyways.
Yeah. Cole has a question for you guys.
Yeah, I got several questions for you guys.
He didn't tell me that. He told me he had one.
Oh,
So,
okay.
Yeah.
Well, here we go, Dave. So question number 1 that I had is, so how many people are brand new to the team this year? Just everyone but 3 people. Okay. How many of you have learned something new in the couple months that we've been doing this? Okay. How many people have not learned something new? Well, Ben, you already know everything, so that's. Okay, so we hope that this is kind of a learning experience for you guys, that you can learn stuff that you don't really learn in classes. So the main question is, how is the admin team doing? Is there stuff that we can be doing better to help you guys do robotics stuff? Is there stuff that we could do less good? I don't know. It's the opposite of better.
There we go.
So is there any feedback for us? If you aren't comfortable sharing it here, you can private message any of us,
Come on
or
after the meeting.
do like a anonymous email to the team email account if you really want to. So is there any feedback for us and how we're running the team and stuff like that, or general questions? Okay. Yeah, that's good to go. Now the next slide.
Mechanical. So last week we did a stand-up from each of the team leads of basically what happened that past week, and we are going to do the same thing this week. So mobility, what we did was we took a close look at the rocker bogie and made sure that the wheels would be the right size, and also they would be centered underneath the rocker bogie system. We also looked at how we're going to encapsulate the motors and the gearboxes we need. So Sasha and Sebastian were working on that, as well as Shui. So we've been working on that quite well. We still need to choose and work on the gearboxes a little bit between the drive motors and the wheels. So that's an ongoing problem. It's going to be either buy one, make one, machine one, print one. We're not sure which direction we're going to go yet. That's Sebastian's job. So hopefully he can hook us up on Slack or something here in the next few days. For those who don't know, the mobility meeting is Thursdays from 6 to 7. And we have pretty much all the parts that we need ordered, and we're just waiting for them to show up. So tomorrow is going to be focusing on the final motors for the NEMAs, the wheel actuation. That's what we're using to turn the front and back wheels, and getting the interfaces between each one of those parts finished. Digger?
So the digger, question.
Yes, so how soon could you get programming an estimate on like the turning radius of the robot, things like that?
Not until we actually build it and test
Yeah,
it.
it's going to take physical testing, you know,
Or I guess an estimate.
or at least the simulation testing.
I mean, the way that the wheels move, I mean, you could pretty much turn on a dime. You could turn the wheels
Yeah, we could.
90 degrees.
Curiosity can do a 0-point turn, so in
Yeah.
theory, so can we.
I think we're pretty close to being able to do that too.
Any other questions for mobility? Cool. Digger?
So for the digger, we've come up with our drum design. This is a cut section of it. There will be 5 of these stacked together in a curved pattern. Yeah, like offset pattern. There you go, like that. So in the end, it'll reach all the way around. This will be our digging and storage mechanism. So
And dumping.
and dumping, yes. So this is designed off of the NASA Razor, which, due to the geometry of the scoops here, can dig and gets the dirt brought into the center here where it will be stored, and then when it's spun the other way, it will then release the dirt. We've also got the actuation down for how we're going to deploy it. There are some kinks that need to be worked out still, but it is basically there. Yes.
How many motors do we need for that on top of?
We're probably going to need 2 linear actuators for the actuation, and we're going to use 1 for the digger. So 3 motors total. Like I said, we're just getting some final things done. We are pretty much ready to start building the prototype as well. And at the same time that we build the digger prototype and the mobility prototype, we will combine it with the chassis prototype as well. That's where we're at. So, any questions?
I got a question.
Cool.
So let's see if I can make this work. Hey, pause. So where is the ground in this model? Is the ground where the shadow's reflecting right now?
No, that is just how SolidWorks was captured. If you go to the end of the video, ground should be, pause it right there. Ground should be, I believe, about here to there. So we will be inside the ground from there. This will be, this linkage here will be in line with the axle for the rocker bogie.
Okay, that's what I want to know is how low is this mechanism?
So it starts off in a above horizontal position. That is the zero position and where it will be stored while not being used and where it will dump as well. So if we were to play this video forward and then play it backwards as well, that would be one full digging cycle. So it would go down. So this is the zero position. It's above that actuator there. It'll go down. It will dig, and then it will come back up the same way. And if we have the desired material, or if we need to evacuate some of the BP1, we'll raise it back up. Probably not to full zero, but then we will spin it backwards and release some of that material. Tina.
So how high does it go to get into the bin?
Right now, the rocker bogie axle is set at 5.1 meters.
0.51.
0.51. Sorry, yeah, that's super high. That's above the limit. So, and I believe I don't quite remember what
So I was actually just checking that now. The collection bin is about, the top of it is about at least level of the table.
So probably about close to half a meter as well.
So is that like when it's in its resting position, that's about how high it is, I guess?
Yeah, this will be able to clear it.
Okay.
That's the idea. Is it'll back up, it'll be cleared exactly. The dumping mechanism or the dumping bin will be about here. It'll spin backwards, releasing all of the material that's accrued, and then go back for another digging pass.
Okay, so I was just, so are we sure this is going to go deep enough to get where we want to go? And not get too clogged with BP1 or whatever?
That is
So-
the goal. We're gonna need to verify this with testing. If not, because we do have experience with it, and it is not easier, but
Different.
a different alternative. We are keeping in mind a belt digger as well. So if any changes need to be made, we will go to that.
That brings a good segue to this wonderful glass cylinder you see here. This is, I'm going to pick it up for the camera apparently. Oh, good lord! So this is the actual depth we need to get to, with the surface being up here. This is BP1 all the way down through here. There's BP2 scattered throughout it, not a whole lot of it. Then there is, according to NASA, a bed of BP2. These marbles are 0.25 to 0.5 inches. What?
Sorry.
In size, so they represent the general size of the gravel. They're obviously not spheres and hearts, but this is how deep we need to go about. So there is BP2 in here, and we've gotten it before, but we can't rely on that. So hopefully we can get into this gravel bed via digging. So if you want a physical demo of how deep we have to get, this is the depth. Also, this is BP1. If you guys haven't seen it yet, this is the stuff they use at NASA.
So don't drop and break this because it will be bad.
They get cancer.
Silicosis.
Is anyone here a Portal 2 fan? Bunch of you. So you know how Cave Johnson dies from inhaling moon dust?
That's why.
That's why. Yeah. All right. Any other questions for Digger?
Yes.
Yeah.
Have you already tested the bucket with that material?
No.
No. This is the first time we're doing this kind of drum barrel design, and so this is what the prototype's for.
Well, as far as I'm concerned, we've never actually dug that deep at all in previous year design.
No.
In theory, the one last year would have gone that low if
In
we'd
theory, but we
actually.
haven't actually done it.
This is true. But
They
that's-
didn't go to the moon before they went to the moon.
That's also true.
Mic drop. All right. Any other questions for mechanical? digger or mobility. Electrical, you're up.
Okay. So electrical, Tina, correct me if I miss anything or say something terribly wrong. We got a majority of what we need for the prototype ordered on Monday. So we have battery packs for building batteries to use on the prototype. We have a rudimentary power distribution system so that we can distribute voltage wherever we need to go on the robot. We ordered brushless motor drivers so that we're able to control the wheels of the robot. We got various connectors that we need. We actually have a breaker / fuse in there so we don't short things out and bad things happen, so bad things will not happen. And we got motors for the drive systems as well, being brushless motors that should work, but that's why we're buying them and testing them out. Did I miss anything?
Sounds about right.
We have schematics for power and data lines throughout the robot so that when we're debugging we can see what data and power goes where, which will be really helpful. And yeah, right now it's just going to be further planning of the electrical systems going into the prototype and talking with mechanical to figure out what prototype electrical area we actually have, so we can start kind of laying things out and figuring out wire routing, and that goes into the mobility as well to figure out how we're mounting motors and all that. Any questions on the Magic Pixie electrical stuff? All right.
Do we have anyone from programming here? You guys had a meeting on Monday, right?
Yeah, so we touched base with John and went through the existing code base and architecture that we've used in previous years, just learning what everything does. We don't have to order a whole heck of a lot yet, but we placed an order for this sensor kit for localization. So we're using RF for the prototype at least to see how well that works.
Cool.
And that was on the report there.
Good to know. I think so. The majority.
You have 2 more slides.
I do. So the majority of the rest of the meeting will be pretty much nailing down what we need to buy tonight or tomorrow morning. So putting things on the purchase list, making sure we have that order sent out so we can have materials to put this prototype together. This is also an opportunity, like Cole said, if you have grievances, questions, concerns, come pull me, Cole, or any admin team over. Or if you're super happy with us, you can do the same thing. I won't complain. And then we can also use this time to actually see our 3D printing capabilities and how deep we have to go. Because I am the team geologist, I took pictures of regolith. This is BP1. This is why we don't breathe it. This is, I believe, 1,000 times magnification, so it's sharp. This will cut your lungs up. This is the BP1 we actually got from Flagstaff, Arizona. I did the testing at Salt Lake Community College with a scanning electron microscope and compared it to NASA's BP1, and it's the same stuff, so we're gold in that regard. We probably just went a few yards down the road. So this is what it looks like. This is what all that stuff right here is. And the stuff we work with is this. This is azimite. So it's still kind of sharp and pointy, but not as much because azimite is processed. So BP1 is mined with explosives and then just left out in the wild, out in the environment. Whereas azimite, it's ground down to various grain sizes. That grain size has a width of 128 microns. That's also at 1,000 magnification. So those are the materials we're working with. We use azimite in the pit because it's easier to work with, we have access to it, and it's safer. So that's all I have. We'll break into the same general groups, mechanical over there, electrical over here. Just what?
Does systems have anything?
Ted?
Hi, I'm Ted.
Hi, Ted.
I'm still here.
Do you have anything?
That is all?
That is all.
Okay.
The system engineering paper was due on the 1st. We got that turned in. So that's a what's the word? It's amazing, yes. So we are done with that part right there, and now he's got to work on the actual system engineering paper. So we have to give him solid data. Along with that, when we do testing, I want to film everything we can, along with 3D printing things. So we're gonna set up some time lapses, get good pictures. We can use both on 3D. What?
Speaking of testing, I'm going to end up writing specific testing metrics for all your different subsystems of the robot, so we can actually get some hard data and really say for sure whether or not these ideas actually work. So be ready.
That's important. Who here has turned in the NASA forms?
The ones that we just like signed and put up here.
Yes.
Oh, yeah.
Like
Online.
yeah, you
Online,
have to
yeah.
go online, submit those forms along with your contact info and all that for NASA.
There is a link on Slack that's pinned on the general channel.
How do you guys get the PDF of the transcript?
So Word can
Okay.
save you that way.
Um,
The transcript.
So the transcript, if what I had to do on Chrome here was select the text of your transcript, right click and hit print and then print that to a
Oh,
PDF.
yeah. Okay.
That's the only way I can seem to get it to work where it prints out multiple pages other than just the first page.
You did it in Chrome.
Chrome did it. In Firefox I had to do a slightly hackier route to something with frames and HTML.
Wait, okay, so you just printed?
Yeah, so both Windows and Mac have an option to basically print to PDF.
Okay.
Windows has a Microsoft print to PDF option. Mac, you have to send it to preview as a PDF, and then you can save it from there.
Okay.
Yeah, so Windows, there's an option. It looks like a printer, but it's Microsoft print to PDF.
Check that out.
Yeah.
One last thing about testing is lots of us are new and we are trying new things for the first time. We don't know what we're doing. It is okay to break things. We can print more parts of the robot. We can, hopefully we won't have to, but we can buy new parts. We don't want to break anything, obviously, but it is okay. It is important that you tell the admin team if you don't know how to do something and ask questions. If we get to a certain part and you say, I know exactly how to design a wheel or know exactly how to design a brace, and we get to Florida and all of a sudden turns out that you didn't know how to do that, we're up the creek without a paddle. If you tell us now, we can teach you, or we can learn together, and we can make that so if we make mistakes here in Utah in our test pit early, and then we can move on forward. So it's okay to not know things. I don't know a lot about robotics. I don't know a lot about the regolith. I don't know a lot about the competition, but we can all learn. So don't be afraid to ask questions. That's one of the most important things when it comes to testing. Cole can't ask questions.
Okay, well I was gonna make a statement instead of asking a question.
Fine.
So,
That's fine.
in addition to his it's okay to break things, Safety Officer Cole says, be safe and don't be stupid.
And don't break yourself.
What?
Don't break yourself.
Yeah, don't break yourself and don't break others. Break the robot, but wear safety glasses, wear earplugs where applicable. Don't stick your fingers into the sharp pokey bits and
Or
don't
pinch points.
or pinch points or the live electrical circuits. So just be overcautious when doing anything because we don't want to lose a team member for whatever reason. So I'm gonna be kind of strict on that. So
And for those who didn't
Yeah.
know, Cole is our safety officer, so
Yeah.
he's gonna be the one that pops out of the corner and says, "Aha!"
yeah, no one ever expects the safety officer. Okay, that actually landed. That's good.
All right, let's break into teams. Go to your separate corners, and we can start buying stuff.
Do we want to talk to you then?